Welcome to today's webinar delivered by JRM Group. Today we'll find out why might consultancy, an OEM and a motorsport division approach engineering projects differently. Now, before I hand over to our presenter, I just wanted to remind everyone that this session will be recorded and shared online later today. The webinar will include an approximately 30-minute presentation, followed by a Q&A session at the end. So please use the chat function to submit your questions and we'll make sure that those get answered. I would also like to thank Hexagon, who are sponsoring today's webinar. Hexagon is a global leader in digital reality solutions that make manufacturing smarter. And if you want to find out more about what they do, please visit their website, hexagonmi.com. So now, without further ado, I will hand over to Steve, who will lead today's presentation. Over to you, Steve.
Just bear with me, we just need to set the right screen up. Yep. Bear with me a second. Okay, we're ready to go. Sorry about that, everyone. Good morning. Thank you for joining this webinar. So I'm Steve Barwick, I'm Head of Engineering at JRM. Just trying to set my screen up. I'm so used to Teams and not trying to. That's better. That's better. Yeah. Thank you for the introduction. So I've added some images in the presentation just to add some colour to the slides because there's quite a few words and really to show the projects that I've worked on. So the images will represent some of the projects I've worked on or where I've worked alongside within businesses that I've worked in where I've gleaned some knowledge. Okay, so what we're going to cover today, introduction, what the intentions are of this presentation, and a summary of my relevant experience. This isn't about me, it's about you learning, but you need to understand the context and where I've got my knowledge from, what drives project durations, description of the teams and the sectors, and the project requirements, how people generate income, what shapes the cultures, the project approach, what we must deliver, and Q&A at the end. Just trying to my screen. So I need to add a disclaimer really just to say that I've written this presentation from my own experience and observations. It's a general guide and it may not align with some of your experiences at other companies. I have spoken to colleagues and friends regarding the material, but again, it doesn't mean I represent everything. It's intended to explain best practice. However, I'm keen that in the Q&A session, you share any of your experiences or anything else that you've got learning-wise that's relevant. The intention is to compare and contrast different philosophies and for you to maybe think about the way you operate and what you might learn from this. Also then to spark any other ideas or discussion you might have. So introduction then. So my experience very briefly, so in motorsport, very early on in my career, I worked for Sparks Dampers, aftermarket damper manufacturer, where I was a designer, development engineer, and then engineering director. So I worked with small race car teams up to international level on touring cars, international rallying. So we had clients as far away as Australia. And I worked with magazines and various things. So I got an insight into race car engineering, probably more at grassroots level than high-end level. At ProDrive, I mainly worked in advanced technology. However, I worked alongside our motorsport team. I worked with them on some projects. At that time, we were running WEC. We were running World Rallycross, starting with the Dakar program. So I left last November. And we were supporting client motorsport projects from within advanced technology. So I got a good insight into really what was happening. In OEM, I spent over 20 years in OEMs. So initially after graduating, I worked for Ford New Holland on the graduate induction program. I was a development engineer in whole vehicle, doing homologation and various vehicle testing. I became a design engineer in tractor systems. I worked in the plant for a little while, and I worked on new programs. So obviously a lot of my work was around Ford process and procedure. In Rover Group, I joined Rover Group as project engineer, and I had a dual role. I was also a damper technical specialist, which meant that I was developing new programs in terms of planning and setting up new programs. I was delivering programs, but also as a technical specialist, I worked closely with BMW in Munich across some of their platforms, and that allowed me to work on new Mini and at that time, new Range Rover, which went from beam axle systems to multi-link. And again, working to Rover Group process and systems, which were a lot derived from Ford and from BMW as well. I spent 10 years at Bentley Motors. Bentley was VW Systems. So there I owned suspension system architecture, air springs and dampers and driveline mounting systems for the Continental GT. This was the first one. It was a developed vehicle. Then I worked on the Cabrio program, and I worked on Mulsanne to first prototype and various other development projects. All of our programs were delivered to Volkswagen Group systems. So I learned a lot about process and methodology from them. Obviously, through that time, I nominated development partners and first tiers. So I worked closely, particularly with Management Sachs, with Continental Tavis on spring and damper units, and other suppliers on various systems, casting companies, etc. So I got an insight into their world, visited all of my supplier factories within Europe, and so you get to understand their methodology of way of working. And for this webinar, really, I'm aligning the first tier business really with OEMs, because generally they operate in the same way, really. Regarding consultancy, quite different. So my experience in consultancy is mainly at ProDrive, nearly 13 years. Then I joined JRM in November last year. So in engineering consultancy, we mainly worked on advanced programs. So particularly where the solution wasn't even defined. So the customer had a vague idea of what they wanted. In some cases they had a defined idea. And then we had to work out the solution. So we were working from concept phase all the way through. I was leading teams in OEMs as well as within ProDrive. And I was also working with other partners. So all of this time, it was really with our own process. I was developing processes within consultancy, within ProDrive, but really our processes were a hybrid really between motorsport and OEM, because in some cases we had to work to an OEM culture, that's what they wanted, and in some cases they wanted us to accelerate an OEM program. So instead of it being maybe 3 years, it might have been 1 year or 2 years, which was quite a challenge. So we need to start at the end, because you need to know what the end looks like. So you need to understand what success looks like at the end of your project. So you need to understand what you're delivering. If you deliver too well, it erodes our profit. If we do too little, we're unhappy internally and externally as well, if we've got an external customer or if the product doesn't perform as it needs to. So we need to get it right, really, and get that blend. You need to be clear at hitting your deliverables. So you need to understand what they are. And often a lot of deliverables, certainly for consultancy, are contractual. And a lot of deliverables might also be safety related and homologation related. And this is the same for motorsport as well. So we need to make sure that safety critical systems are safe, they perform appropriately, and they meet homologation requirements. So it's really important that you understand this. Also, then managing the team through the program, you need the right pace. It's very common for all of us to have a big panic at the end. And we always say we won't do that again, but we do. But again, it's thinking about where you are, understanding where you are, and thinking about how do we manage the project so we don't have that panic at the end. And we come out of the project feeling positive and really proud of what we delivered. For OEMs, they need to deliver, they need robustness because warranty costs a lot of money. Also, the client's got to perceive high value from what they're buying. But of course, if they over-engineer the product, it erodes profit. And it's the customer shouldn't be seeing where the OEM's cutting back. They just want to see the positive, really, in that. And so OEMs must manage launch really carefully. They must manage the design and development cost because it's hundreds of millions of pounds quite often. So that's quite careful. Now, motorsport, of course, what you've got to deliver is you've got to get the car on the start line. If you don't get the car on the start line, you're just not getting points, you're not getting experience, and you're losing massive credibility. So that must be achieved no matter what you do. Now, the other thing, though, for motorsport is you want to see the potential in the car. So although you get on the start line, ideally, you're delivering a car that shows potential for the season so you can deliver a good season. And it might be that you don't want to show your pure potential on the first race, because in some race series, as you know, you can get basically you've got a performance rule system that can affect that. So project durations, what drives them? Quite often we don't look at what really causes a project to be the timeline it is. So I'm trying to explain this. Now, I think motorsport, we all understand, straightforward, in that it's seasonal. It tends to be 9 to 12 months. Your first race is defined by the seasonal calendar, so you plan for that. You might do parallel technical advancement or innovation development in parallel to the program or ahead of the season. And of course, you've got to be mindful of rule changes. So what you also do is align your technology so you can maximize the benefit if you see an opportunity in changing of rules. OEMs generally typically is a 3-year program. OEMs are consistently trying to shorten this, but they never always quite achieve it. So one of the ways of potentially de-risking or shortening a 3-year program is to do shelf engineering or pre-development, as the Germans call it, ahead of the main program. And this is where you're developing risky technology or technology where you're not sure the value of it and what it's going to cost and how it's going to perform. So you run this outside of the main program. Then traditionally 3-year programs allow 2 summers, depending on when it starts, and a winter. You need at least 1 winter for physical testing. However, modern test tracks have developed such that they've now got artificial surfaces and indoor cold surfaces, etc. People are more readily using New Zealand. However, genuinely, OEMs have now noticed that the warming of the planet is seriously affecting their winter testing. So this becomes a real challenge. Of course, also, though, they're looking for opportunities to deliver more representative virtual engineering. How do we model vehicles and systems so they're more representative, so we could do more work early on in the project And this is obviously a lot cheaper and faster than making prototypes, because prototypes need to be functionally representative. That's the challenge we've got. Technical understanding, level of complexity. So this affects OEMs because what they've learned before feeds into the next program. So either from the shelf studies or from previous vehicle, because usually, whether it's trucks, buses, cars, it's an evolution, not revolution. Yes, it's revolutionary at the moment in some cases in terms of electric vehicle drivelines and electrical architectures and lane change technology and vehicle understanding of situational understanding. But fundamentally, OEM engineering at first year has been a further enhancement and development of what you've known before. So programs have to decide what the mix is and what the risk is, with that technical understanding and that confidence. Same with facilities and human resources. They make a judgment on what's available when you're running multiple programs. Now, you imagine now for an SME that's just starting building their first vehicle, we've got a lot of electric vehicle startups at the moment. They've got to do everything in their first vehicle. So they've actually got to do the pre-development, they've got to do the design, the development, and do everything from scratch, which is a massive challenge. So inevitably, they'll try and buy or partner with people where they can bring in technology to do risk to that platform. If we then look at consultancy, this is very different because often the complexity is very high because the answer isn't understood. So clients come to consultancies because they want it faster, they want it different, or it's something that they don't understand how to do it themselves, or they just don't have the resource to do it. So there's a lot of competitive tension there. So component lead times have a big effect because often the project is much smaller than 3 years, and resource and facilities are really key as well, because the consultancy has to plan the project and plan to deliver it so that they can utilize the right people on the project at the right time, and they can utilize the right facilities, which often they're hiring. And obviously, how do they manage that technical uncertainty? What do they allow in terms of risk for costing and timing that technical uncertainty? So we've got 3 different teams, really. What do they look like? This is a bit of a generic organization, but it's really to just help us understand what a motorsport organization looks like. A lot of you will be familiar where you've got your MD of motorsport. It can be a total company or it can be part of a company. Under the managing director, you've always got a director or a head of engineering. Then you've got other functions like manufacturing, logistics, etc. And then under the engineering director, you've got a number of chief engineers for departments. Depending on the size of the organization, it might be one engineer that covers all of engineering. It might be several, where here, for example, we've got engines, chassis, electrical control, because electrical and control is becoming more significant now. Then under those chief engineers, you've got a group of engineers. It could be 2, it could be 20, that have got various levels of seniority, various levels of technical understanding, and then Motorsport is good at employing graduates as well. So then they come in and learn and develop. For an OEM, a very, very different structure in that you've got a number of large department directors. A director could have a team of 500 engineers working for them. Manufacturing director might have 3 facilities. An engine plant and probably 3 car plants. So obviously it's a huge operation. So what I've cited here, we've got whole vehicle team, which look after the whole vehicle. We've got the engineering team and the program director. They are sort of the governance team that check and challenge. They're like the police that understand what's going on and report, and also coach and support the engineering team to make sure that they're delivering the program to process and delivering it to plan. So if we look at the engineering team, so typically you've got chief engineers under the engineering director for each department. So you'll have a chassis department, a body department, electrical, etc. Many departments. Within those departments, typically there might be 100, 120 engineers or more, depending on the size of the OEM. So then they will have group leaders look after specialist areas. So for example, steering is a system where you might have EPAS, hydraulic, steering boxes, steering racks, etc., depending on the products. Then you've got, under that, you've got various engineers, a team of engineers embedded within the steering system. You'd have a technical specialist, etc. Now, you see in yellow then, so chassis chief engineer employs a module leader for chassis. He's everywhere. He's talking to people. He's making sure that the team reports out their status at key gateways, which I'm going to come on to in a minute. That module leader, his manager is within the engineering team, but he's got a clear link to the program director via the program chief engineer. So every OEM program has a chief engineer. He's like a guide. He asks the awkward questions of the engineers. He's a generalist, so he knows a little bit about everything. Normally a well-experienced engineer that can ask really awkward questions. Have you done this? How have you done it? Why is it going to work? Why is it going to work? Are you sure it's going to work? That kind of thing. So structure, and sorry, just going back one. So I've deliberately not shown what the organization looks like for consultancy. Consultancy, they will flex the organization for a project depending on the client. So it could look like a motorsport project where you've got an engineering director replaced by a technical leader, and then you've got a team below. You've often got a program project person like an OEM that's making sure that the team are honest and they're reporting into the client and they're challenging themselves. If they're working for an OEM, often the OEM wants them to be part of their structure. So embedded, I've worked as an embedded team. So in the past, one of my roles has been effectively a chief engineer role in chassis, where I've run a team within the department in an OEM, etc. So you can see that consultancy tends to be a hybrid of these. We look then at what does the organization structure look like. This is quite generic, but it's really to help you understand how an OEM might work. And normally it's a matrix structure, really. So you've got the 3-year program along the top. So you start with the planning phase. So you cost the project. You think about what are the conceptual solutions, how many vehicle derivatives, etc., etc., and what are the new concepts that we're going to evaluate. It might be a new SUV that goes from it might be a pickup derivative of a previous SUV. So then it's a new concept for the OEM, learning from the previous SUV into a pickup architecture, etc. And so you've got then that concept evaluation, which is virtual, a lot of numbers, a lot of target setting, a lot of planning. Then you start building your concept in your virtual engineering tools. You go into virtual engineering development. You then tend to go through a gateway for a build, the first build, which is virtual, bringing in manufacturing. What does it look like virtually in CAD? Can we build it in CAD? The tools are so good now that they often do a virtual build. What this does do is it brings all the teams that are vertical together so no one can hide. So basically you've got the business team, which represents all of the facilities, manufacturing, etc. Design means really the styling team, interior, exterior style. They influence homologation, they influence the interior systems, team design, and the body outer. Engineering teams, all the engineering teams are within the box there. And manufacturing and test and development, which is whole vehicle. So they have to work together in parallel. So the diamonds represent the gateways where they come together. So although they communicate across team, the gateways are at the point where officially everyone has to show their real status on the project to everyone and to the directors and ultimately to the chairman, so then they can understand progress. And the program teams work with the engineering teams to pre-prepare documents that describe the status, the level of risk, etc. So then to go through the gateway, the engineering teams present how they've solved the problems, where they are against plan, and what outstanding risk might exist, etc. And then the senior managers make a judgment if the team can go through the gateway. And because bear in mind, you've got to bring engineers together, there might be hundreds of them that are not co-located. It could be even in different countries. And then you've also got to link in suppliers as well. So that's how we deliver a project. Motorsport, similar in some ways in terms of philosophy, in that you've got a plan that's defined, but it tends to be 1 year, as we mentioned earlier. You've got to define your requirements, your specifications that you defined internally that you want to meet. You then evaluate different concepts that might give solutions to meet those targets. Then you work those targets through a virtual and then a physical. But traditionally, motorsport have been more physical in terms of testing and doing internal rig testing, etc. But more and more now, we're doing more virtual engineering because it's complex. And to get those incremental gains, those small improvements, it's really difficult because motorsport teams tend to be less broad, but very deep in understanding and capability to get those small improvements that you need to make. And often to get a 5% improvement, you might have to change a lot on the car. But again, we've got the teams that are aligned, but often also motorsport teams, as well as being a larger number, can be co-located in one room, quite often in one building, certainly. So they're daily communication. So we need less complex systems. And again, consultancy tends to be a hybrid of these plans, really. So project inputs. So really, this is something we don't always think about, but we need to think about at the very beginning is what inputs do we need to allow us to do the planning, to allow us to cost and think about the project. So it affects what we do quite a lot. So in terms of motorsport, we have a budget. I'll explain about where that comes from a little bit later. But every project has a budget. You've got a level of technical understanding from your previous learning, as I mentioned before. You've then got to look at the rules and requirements and how far do you push the technology, and then how do you get it homologated? It's got to meet that requirement. And you're looking for advances. You're looking for technical advances that you can deliver within the program to make the car ultimately go faster or to drive longer if it's Le Mans. We know that fuel efficiency now is really important in racing. What partners do we need to bring? Because generally motorsport will do everything behind closed doors. They don't need to answer to anyone. It's all in-house. However, they still need to deploy technical specialists. So for example, brakes is a good example where they will buy in a foundation brake system and work with the brake system manufacturer to integrate that into the car. Also, motorsport is about the event. It's about understanding the event, understanding the geography, the surfaces, how does the car work better in the event, where is the event, how do I get to it, how do we get all my kit to the event, etc., how do I service, etc. Very important for rallying, for Dakar, as well as obviously high-end motorsport and circuits around the world. So that event strategy is really key. For OEMs, really, it's first of all, who's my customer and who's the market? Because that drives a project. Also, what are the predicted volumes? Going to be realistic, and what option fits? Am I going to fit? Because it's all trying to sell the number of cars, getting the right combination between not making it too complex, not too many options, versus offering the customer what they want. The points of sale can be in different countries, so the legals vary as well. So you've got a massive homologation team that are planning and guiding the engineering teams to what they have to deliver. This all affects the budget. So really, what can we afford? What can we bring from previous programs? And therefore, that dictates the level of change, because you've got a balance between technical advancement, performance, fuel economy, interest from the customer versus what we can afford to deliver. Consultancy, quite different in that it's mainly about the customer. Is what does the customer want? What's the objective of the project? And what do we have to deliver for the customer? So consultancy will work with the client and define very clearly what the deliverables of the project are. They will define very clearly the budget. Often this is very challenging because the customer wants to spend less than what the consultancy thinks it's going to cost. So there's a lot of negotiation there. Then they will then come up with a timeline and a proposal. and often gateways are defined, because this helps the consultancy. It also helps the client, because often the client wants to know what the consultancy is doing. They don't want to wait to the end. They're not interested. They're interested in progress, interested in it looking appropriate, and where's my money being spent. The consultancy has to plan the resources and the facilities. They need to have the right technical people, and they need to assign that. Of course, the client wants to know they've got the best people. And of course, in between all of this, the consultancy's got to train new people as well. So we're only in it for the money. So everything we do, unless we're probably the government, we're there because we need to get paid, we need to make profit so we can exist, and so we can advance and we can invest in our future. So in motorsport, most of the money comes from sponsorship, and it comes from driver bringing budget to the program. And the driver's budgets can be coming from all areas, from personal income, from sponsorship, etc. Sometimes motorsport companies for certain programs have to invest internally, certainly if they're making a step change in terms of what they're racing or what they're doing, which might be different from before. And so income then from motorsport teams often then comes from selling off motorsport related products. So generally, from my experience, it's very hard to make money out of racing. So you make money out of the IP you generate in racing. Often this is selling replica product, or for example, thinking back to rallying, showing my age, when we were building Group N rally cars, is ProDrive made money from Group N rally cars and didn't make money really from the world, from WEC, from the rally program. OEMs, obviously, they make their income from customer, from market sales. This can be a challenge because it depends on launch cost, it depends on D&D cost, because obviously they've got to think about, on some derivatives, the halo product, the high-end product, they might make a lot of money if they're very clever, and very less margin from the less loaded, the simpler derivatives. Sometimes it works the other way. So profit per vehicle, per program. Selling innovation is now becoming more significant for OEMs. They might sell innovation to a competitor or to someone else. Platform sharing, so they're selling technology, probably sometimes within groups, sometimes again to another OEM, where OEMs enter partnerships where they're sharing platforms, and money often exchanges there. A lot of money is made out of servicing, often not from the dealership itself because they're separate businesses, but from selling parts. And obviously in last few decades, as we all know, insurance and finance, they're quite lucrative. So consultancy, money is made from the client in terms of delivering engineering, and often in delivering product, making things and assembling things. And it might be that the client comes to them directly for purely manufacturing and assembly and not the engineering. They can be advisors. Typically, large consultancies are advising the government, they're writing white papers, and this generates a lot of income from them. It means that they're generating income almost when they're sleeping, certainly in selling innovation in terms of licensing, design, software, and training material. They are making money when they sleep. Cultures need to be different. In some ways we're similar, in other ways we are different generally. I think we'd all recognise that a motorsport company is different from an OEM that's different from a consultancy. So why is this? I think some questions to really think about this is what influences the way we work, what we do and how we do it. Sometimes we don't think about this. Does technology influence this? And what technology can influence us in the way we have to use it or use it. Certainly CO2 reduction is influencing the way we work. And how do we deploy that knowledge and experience? What's the result then? Each sector must operate differently. I think what I've covered earlier sort of explains that really, and how influences our culture and vice versa. So we end up with a culture that ideally suits what we need to do. However, I think the real opportunity Maybe this webinar might help you think a bit about what could we change, what might we want to change in the way we deliver our culture, which might improve our quality and our efficiency, and ultimately how we make more money. Or also, what's really important for everyone these days is your happiness. So you need to be happy in your work, you need to be enjoying what you do. And if you enjoy what you do, usually you'll deliver more efficiently, more effectively. So in a bit more detail then regarding culture, I've tried to explain the different cultures within different areas. So looking at motorsport initially. So as we mentioned earlier, motorsport people are very experienced, particularly in a certain race series or program or type of motorsport, unless they're changing. So they know what they're doing already, and they've set their organization around what they do. So the core team has very significant and relevant experience. They can do it almost with their eyes shut, which is really good. And that's why you see some amazing designs and amazing cars being developed. What often you don't see is what's underneath all of that. So obviously, and how they do it. So they're developing technologies, techniques, and the way they apply that. So technical development, again, I mentioned before, is looking at those really hard to win incremental gains in performance that will allow you to get the 10/10ths over your competitor. This means a lot of virtual and physical experiments. And I think there's a lot more virtual experimentation today than what it used to be. The team still needs to know what they have to do. It's really important. So they need to have leadership, they need to have management, they need to be absolutely on it, honed to perfection and guided. And they all need to be pulling in the same direction. This is often the case. So the whole team needs to work very closely together. They need to be coordinated, and they've got very little time to do it. So they need to be very effective. So if we look at OEMs, as I sort of mentioned earlier, level of platform change massively affects programs. If you introduce too much change, it's really risky and hard to deliver and can cause confusion. So an OEM tries to limit the amount of major changes within a new platform. So the departments have to work together. Departments are very specialist, and drilling down into the department, if you get a technical specialist, so for example, HVAC, he will know every single thing there is to know about HVAC systems, but he won't know probably very much about braking systems or about how to make a car handle. So again, you've got real specialists in real areas, but they've got to draw that out into a whole vehicle. So they've got to link the departments through virtual engineering, through managing, which is really challenging. So management and leadership is really key. Therefore, process to guide them on what to do is really, really important. So virtual engineering allows them initially to see where they are, where they bring the car together virtually. Then you can see if you've got packaging clashes, you can now model a vehicle, so you can drive the vehicle to see how it performs virtually. Mentioned teams are very large, and also they have to use first tiers. First tiers are even more specialist in what they do. So for example, you might have an air spring supplier that can model air springs, that knows everything there is to know about air springs. Then the OEM integrates the air spring, working with that first tier into the vehicle. Revolution and evolution then can be challenging. So often it's managed as an independent project because it risks the main project. And so new vehicle introduction needs to be phased. So the OEM thinks about the existing platform and the sales of the existing platform and needs to reinvigorate the customer by bringing in the new platform at the right time, but not bringing it in too early or too late. Also, that the end of the project, the last year, 6 months is really challenging for the OEM, where everything comes together and you're doing a quality maturation. Sometimes this costs the business because it causes delay that becomes very expensive. So that again affects the culture in that, how do we deal with this? What do we do? Consultancy, as I mentioned earlier, a lot of focus is required on solving a problem. What do we need to do? Often there aren't obvious solutions, so we need to understand what they are and how we deal with that. So the consultancy if they don't know what the solution looks like, they've got to develop it. They've got to develop a functional understanding of the system they are intending to create. So what does it need to do? How does it need to do it? How much does it need to do, etc.? Where does it need to work? And that allows them to grasp an understanding. And then from that functional understanding, they can set targets and they can develop an understanding and develop concepts which might meet that requirement. So typically they're working in technology readiness level of 2, which is just at the end of the scientific phase and laboratory phase, into 6, which is sort of first prototype, really, so high risk areas. So this means that the engineers are not specialists, they are generalists. They have to have a lot of experience of a lot of things, and they have to work from first principles. So they tend to use physics and mechanics, they tend to use engineering tools, they tend to do a lot of virtual experiments to make gains in understanding on what the solution might look like. And sometimes the processes they use can be a hybrid, as I mentioned before, between Motorsport and OEM. The client demands technical reports. Internally, they need technical reports, so report outs are really important for a consultancy to satisfy the client and to define this learning, and it puts rigor into the project. And so also often what they're working on has to be made, and often it's a pre-production or a prototype, so and a consultancy needs good understanding of manufacturing technology. So the approach, generally I'm saying that the fundamentals of the approach are common across all 3 sectors. However, how they're realised is different, as we've described before. And you know, I've put a few points here that sort of summarise that, what we've covered really. So we need to have a clear direction. We need to set measures to evaluate our performance. We need to have a method of monitoring our performance. And that again, the rigour on that depends on who you are. Probably the most extreme is the OEM, and Motorsport probably don't need that level because they've got trust and they've got close working across the team. So they need common methods of communication. And roles and responsibilities need to be clearly defined in all organisations. So we need a structure, we need a very clear reporting structure. Everyone needs to know what their role is. External partners need to be defined, and they need to be very clearly linked and integrated into the process. And in some cases, you don't want them to know everything that's going on. So processes need to be defined and utilised effectively to guide the team. Leadership skills are more important than I would say a lot of people realise. And governance is important, where the managers and the leaders aren't getting traction. Governance needs to take over, where the seniors need to push and poke. And we need to also decide, is it good enough? Engineers want to do the best they can, and engineers want to over-engineer. That does cost money. I shouldn't say this, I'm an engineer, but ultimately, when is it good enough and is it too good? So I think this is the last slide, end of the project deliverables. What do we need to deliver? And this is really a summary. So obviously we have to deliver to the plan that we've written. We have to deliver the system or the car. We have to deliver the technical specification. From that, we need to have had an understanding of what we've delivered technically. If it's a consultancy, an OEM, they want to know that regarding report outs. And we need to also learn about the opportunities through delivery. What have we learned? How can we take that learning and put it into the next program? Because that makes you more efficient. We need to identify all of our costs, so we can roll up the costs and understand what margin we've made at the end of the project. Lessons learned in all areas. This isn't always captured, but it's very important. I think more and more today now, people appreciate the value from lessons learned in the project. All engineering releases must be complete. This means you've fully documented exactly what you are building. In some cases now, we use CAD, but in some cases we may not always release a drawing. Usually we do, but modern CAD systems now are moving towards having the quality data embedded within the CAD model as well. And internal and external customers and stakeholders need to be happy with the result. So I hope that was helpful to all of you and interesting to hear your questions. I don't quite know where I am with timing. I've not really been slightly...
Hello, Steve. Thank you very much for that. We do have a couple of questions that were sent prior to the event today. How does a consultancy manage risk? Could you tell us a bit more about that?
Yes. So first of all, in the planning phase, a consultancy typically will run a risk register. So good program management, good philosophy is to think about risk in the very beginning. What are the risks? COVID is a risk. People going sick is a risk. So it's not just technical risk, it's thinking about the risk for the whole project, thinking about the facilities, thinking about the company, resources available. So a risk register is probably the way they do it initially. Then obviously they would use design tools like design FMEAs, functional analysis, that kind of thing, to allow them to think ahead, to look at what the risks might be.
That is great, thank you. Another question we've got is, how might a motorsport company improve efficiency? Okay,
I touched on this a little bit. I think now more virtual modeling, more virtual testing. So traditionally, ultimately, wind tunnels have been used for aerodynamic understanding, and now we've used CFD. CFD is common, and that's kind of pretty well correlated. But beyond that, whole vehicle modeling, hand calculations used to be used for basic settings, basic car setup. But now with modern tire models and whole vehicle models, we're getting good correlations, so we can run experiments. We can use simulators more. The top teams are now using simulators for evaluating vehicle performance on the track, for driver training, etc. So I think I would say then the improvement in efficiency is around using virtual tools, really.
Thank you very much. One final question. How can an OEM reduce project duration below 3 years?
Yeah, again, I think use of modeling, although they are doing this already, I think it's probably more parallel activity, more shelf engineering. So OEMs are employing universities more often now. We're doing more research programs. Obviously, the large OEMs have got embedded research teams within them. So then if you deliver that shelf engineering, you've got less risk in the project. So linking that virtual domain with a physical in terms of correlation of physical and virtual models, I think it's probably more that parallel activity of how can we do things in parallel, how can we work more efficiently. I think the other key area is also reducing failure modes, where you would sometimes go through a gateway, but actually that gateway would have a lot of risk. And I think that more work can be done in the earlier phases of the program, where it's less costly to understand the concept more thoroughly and evaluate the concept more thoroughly, rather than wait till you have a physical build and evaluate it further down the line. So as you progress through an OEM program, every year, the cost of change increases rapidly, and the opportunity for change reduces rapidly as well. So at the very first year of an OEM program, you've got massive opportunity to consider change, and change costs less money because you've not tooled anything, you've not built anything. So you can afford to probably do more experimentation and take more risk early on to then choose what your options might be, if that helps.
That's very helpful, thank you. We've got 2 more questions for you. How do the identified lessons learned get communicated and used to make real improvements in future projects?
So in my experience, often the project engineers collate this information because they're neutral. Getting lessons learned, getting engineers to be open and honest about their feelings about what they've learned can be a challenge, because we're proud of what we do, or sometimes we don't want to share things that have gone wrong. So you've got a real challenge, but I think that if you develop a culture that recognizes that lessons learned is a benefit, then people will talk. So getting people to put their hand up first and to talk is probably the first step. And in businesses I've worked in, that's always been a challenge because they're nervous about peer pressure, about that situation. But then, of course, how you facilitate that is workshops where you might get a group of people from a project together and they'll bounce those ideas off each other, and then the points will get teased out in the conversation, if that makes sense.
Thank you very much. Final question, how do you define a project from deliverables to times and materials?
So how do you define a project from deliverables to?
Time and materials.
Okay, yes, good question. So you break the deliverables down into the understanding, in terms of the technical understanding, the method for delivering that piece of work, thinking about the resource you might need, the uncertainty, the facilities, etc. And so you will build a picture of each deliverable. First of all, you would challenge it. Does it make sense? Do I understand it? But when you've been through that, sometimes you might mind map to get that clear understanding, reflect it back to the client, because sometimes what they thought they wanted isn't what they wanted. And then, yes, and then you would use a combination of spreadsheets, probably a timing plan, often Microsoft projects, where you can break the deliverable down into steps, chunk it down, and then you can think about the activities and think about the resource that you need and then the time you need. And gradually you build up a plan that's got all the elements in it and how they link together, and then where you might have some synergies as well. And so Microsoft Project is very good at doing this, where you can collate that information. You end up then with a resource plan and a timing line. And then again, you can go through it again and test it and check it and change it. One other last thing on deliverables, you will also test that against a roles and responsibilities matrix. So this is a good thing where across the team and with the client, or if it's just in the team, is you clearly define the roles and responsibilities across the project, who does what, which then will affect who works on what, to make sure ownership is clear as well.
That's great. Thank you very much. I think that is all we've got time for today. Thank you very much. It has been a very insightful presentation, and I'm sure all of our attendees have gained some really useful knowledge from this session. I want to say a very big thank you to all of our attendees for joining us today. Before you log off, please take a moment to complete our poll, which will be live shortly, as your feedback is really important to us. Please visit our website if you want to find out about some of our upcoming events and webinars, and we hope to see you soon again. Have a lovely rest of your day. Thank you.
Thank you, everyone. Cheers.